Within the darkest corners of our solar system, a mystery shrouded in secrecy has just been revealed. The mysterious world of Pluto has always been a source of fascination for astronomers and space enthusiasts alike. But now, NASA has just declassified never-before-seen photographs of Pluto, revealing surprising secrets. Pluto, once hailed as the 9th member of our solar system's club of planets, now holds a unique distinction as the most massive dwarf planet known. It resides in the distant Kuiper Belt, a realm far beyond the influence of Neptune. Here, Pluto finds its cosmic neighbors amid a variety of rocky and icy companions, even brushing up against sizable comets, each with a diameter greater than 62 miles or 100 kilometers. The year 2006 marked a turning point for Pluto when it faced a cosmic identity crisis. Astronomers and the general public became involved in heated debates after its reclassification as a dwarf planet. However, Pluto's journey to celestial fame began in 1905, when American astronomer Percival Lowell first hinted at its existence. Lowell was a keen observer of Uranus and Neptune, noting singularities in their orbits. He theorized that the mysterious culprit was the gravitational force of an invisible celestial body. Intriguingly, Lowell attempted to predict the location of the hidden planet in 1915, but unfortunately did not live to witness its actual discovery in 1930. Credit for the revelation of Pluto goes to Clyde Tombaugh, who worked diligently at Lowell Observatory. Tombaugh's discovery validated Lowell's predictions and the theories of other astronomers. Interestingly, the name Pluto itself has an interesting history. It was not coined by scientists, but by an imaginative 11-year-old girl named Venetia Burney from Oxford, England. She suggested her name to her grandfather, who then passed it on to Lowell Observatory. The choice of Pluto pays homage to the Roman god of the underworld, Pluto, and remarkably coincides with Percival Lowell's initials. Pluto's icy surface is home to another captivating aspect. It is among the coldest places in our solar system, with temperatures dropping to a frigid -375 to -400 degrees Fahrenheit. Images captured by the Hubble Space Telescope have revealed changes on Pluto's surface, hinting at possible seasonal variations. Pluto is very far from the Sun, about 40 times the distance between the Earth and the Sun. Its orbit around the Sun is long and takes 248 Earth years to complete. In terms of size, Pluto is small, with a radius of only 1,188 kilometers, much smaller than the planets and some of its lunar companions, such as our Moon. Its mass is only 18 times the mass of our Moon. Due to its small size, it has been considered a dwarf planet since 2006. Pluto has had an interesting journey through space, moving closer and further away from the Sun over time. Pluto is moving further and further away from the Sun, like a car moving away from its starting point. In the year 2113, it will be very far away, almost 49.3 times farther than Earth is from the Sun. This makes it appear distant and difficult to see, even with powerful telescopes. To study it better, we sent a spacecraft called New Horizons in 2006. It took a long journey of 9.5 years to reach Pluto. Along the way, the spacecraft took photos of Jupiter and sent them to Earth. Finally, in 2015, New Horizons reached Pluto and allowed us to discover more about this mysterious world that had kept its secrets hidden for a long time. New Horizons traveled beyond Pluto and collected a lot of interesting data. It then sent that data back to Earth, which took quite some time. This is like taking photos on a distant trip and then sending them home to share with your friends. It's important to know that New Horizons didn't stay orbiting Pluto. It just happened to pass by him. This allowed him to continue exploring other things in space after Pluto. Scientists were excited to discover what's inside Pluto. They think it has a large core made of ice, water, and rocks beneath its surface. Around that core, there is a layer of ice that can cause interesting movements on the surface, like tectonic plates on Earth. Finally, on the outside, Pluto has a layer of frozen gases such as nitrogen, methane, and carbon monoxide. This layered structure makes Pluto an intriguing place to explore, like a cosmic treasure waiting for scientists to unlock its secrets. Pluto's surface is extremely cold, almost like a giant freezer, with temperatures dipping very low, around -213 degrees Celsius or 60 Kelvin. When we explore Pluto, one of the most striking things is a region called Tomball. It looks like a big heart, and is very large, covering a quarter of Pluto's surface. It's like finding a giant, frozen heart in space. This region has a flat, bright part called Sputnik Planitia, which is like an extensive plain. But the most interesting thing is that Tomball's surface is covered with a layer of ice that shines with a special color. In some places, this ice sheet reflects up to 90% of sunlight, giving it a shiny, almost magical appearance. It's like it's part of a fairy tale. So, when we look at Tombo Regio, we are not seeing just normal ice, but a bright, enchanting spectacle that adds a magical touch to Pluto. In a region of Pluto called Sputnik Planitia, what really stands out is that it doesn't have many craters, which means it's quite young in geological terms. This is thought to be due to a large collision with another space object about 100 million years ago. That collision created a huge crater that then filled with frozen water, forming the plains we see now. You can think of these plains as giant ice pancakes with interesting shapes. In another part of Pluto called Tombo Regio, there are impressive mountains. To the west of Sputnik Planitia are the Hillary Mountains, which are very high. If you go south, you will find the Townsend Mountains, some of which are even higher, becoming the tallest mountains on Pluto. What is surprising is that these mountains are mainly made of ice, although they are as solid as rocks due to the low temperatures on Pluto. There is also a deep basin that scientists believe could be the remnant of an ancient ice volcano. All of this helps us better understand what Pluto is like on the inside and how it has changed over time. Although Pluto is far away and cold, it is a very interesting place for science. On one part of Pluto, east of Tombo Regio, the land is darker and full of craters, like a frozen history book showing us that Pluto has changed over time. Despite moving away from the Sun, its atmosphere has become denser because the Sun causes nitrogen ice to evaporate and move toward the poles. Pluto also has a unique orbit, and always shows the same face to its moon, Charon, due to gravity. It is a special place in our solar system. So far, we've explored some of the mysteries and fascinating features of Pluto, but now we'll turn our attention to another celestial giant in our solar system. For years, astronomers have been attracted to Saturn because of what emerges from an ocean hidden under a layer of ice. Now, there is a new twist in the story. Researchers analyzing data from NASA's Cassini probe have spotted mysterious objects nearly 2,000 miles long passing through Saturn's clouds, leaving glowing trails in their wake. This discovery took scientists by surprise, who are baffled by flying saucer-shaped objects. This incredible revelation on Saturn's moon has fueled interest in the search for extraterrestrial life in our solar system. What is this saucer-shaped thing? Could there be intelligent life beyond Earth on Saturn? We investigate the UFO sighting near Saturn that is shaking up our understanding of the solar system. A NASA spacecraft has obtained a stunning view of a small flying saucer orbiting within the rings of Saturn. The new images initially led Cassini scientist Carolyn Porco to believe they might be works of art, but they turned out to be authentic. The saucer turned out to be a small moon called Pan, which has a diameter of 21 miles and occupies a gap in Saturn's A ring. Its distinctive shape is due to an equatorial accretion disk, a thin layer of ring particles stuck to Pan's waist due to its weak gravity. Pan is not alone in its peculiar appearance, as another small moon, Atlas, has a similar shape for similar reasons. On the cold moon of Saturn, researchers have discovered phosphate in water, a vital component that has never before been found in an ocean outside of Earth. Enceladus, one of Saturn's 145 known moons, has attracted the attention of astronomers and astrobiologists due to its intriguing geological activity and the possibility of extraterrestrial life. Enceladus is believed to have a subsurface ocean of liquid water in contact with its rocky mantle, opening up the possibility of chemical reactions that could support life. The presence of salts and organic molecules in the feathers expelled by the Moon reinforces this possibility. Furthermore, the detection of silica nanoparticles suggests the possibility of hydrothermal activity at the bottom of Enceladus. These discoveries increase the possibility of finding extraterrestrial life on this moon of Saturn. Multiple space missions have investigated Enceladus. Although the 2 Voyager probes flew by it in the 1980s, the most detailed observations of Enceladus were made by NASA's Cassini probe after its arrival at Saturn in 2004. Cassini discovered the subterranean ocean and geysers on the Moon from 2004 to 2017. The Cassini probe investigated Saturn, its rings and moons for about 13 years. Samples of ice particles and water vapor emitted by cryovolcanic geysers erupting from cracks in frigid Enceladus were collected and analyzed by Cassini's Cosmic Dust Analyzer. The frozen waters of Saturn's moon Enceladus contain the building blocks for life. But does it have life? Phosphorus, the rarest of the 6 elements that make up life as we know it, has been discovered on the ocean-bearing moon in our solar system for the first time. Dr. Christopher Glane of the Southwest Science Institute is part of an international scientific team that has discovered important evidence suggesting the existence of the key component of life beneath the icy surface of Saturn's moon Enceladus. The discovery is based largely on data collected by NASA's Cassini spacecraft. Phosphorus-containing phosphates have been discovered in the deep ocean of Enceladus. Phosphorus is an essential element for the construction of life. Enceladus is an icy moon with a vast ocean of liquid water hidden beneath its icy surface. Researchers have already discovered other components essential for life, such as carbon, hydrogen, nitrogen, sulfur and oxygen, in water on the moon. However, phosphorus, which works with sugars to form the backbone of DNA molecules and also helps in the repair and maintenance of cell membranes, had eluded detection until this point. Now, Mars has almost become commonplace in the search for life beyond Earth. Saturn's cold moon Enceladus was once overlooked by astronomers who believed that Europa, one of Jupiter's moons, was too warm for life to develop. However, several recent scientific findings, including possible chemical signatures of life, have shifted scientists' focus toward the likelihood that such extraterrestrial bodies actually host microorganisms. There are intriguing hints that simple life forms may have evolved on other planets and possibly moons in the solar system, and scientists are looking for life on exoplanets around distant stars, as well as radio signals that could come from distant civilizations. A report on Enceladus is one of several recent scientific papers discussing the search for traces of life in our solar system. The Cassini spacecraft sampled geysers emitted by Enceladus between 2005 and 2015, and the results were published in the journal Nature Astronomy. Methane and hydrogen were detected in large quantities by the probe, supporting the theory that bacteria have adapted to life near hydrothermal vents on the ocean floor. The ocean on Enceladus is hypothesized to be between 12 and 15 miles deep and covered by a thick layer of ice up to 20 miles thick. Scientists believe that heat is generated in the Moon's core due to its tectonic motion, and the Moon is influenced by tidal forces created by its orbit around Saturn. The phosphorus was detected after years of analyzing data from Cassini's instrumentation as it zoomed past the icy Moon. The 6 elements carbon, hydrogen, nitrogen, oxygen, phosphorus and sulfur are fundamental to the biochemistry of life on Earth. Hydrothermal vents like those on Earth that release nutrient-rich water into the ocean may be fueled by tidal heating on Enceladus. Because biology is still in its infancy, even the most fundamental notion of life eludes scientists. Although scientists can confidently state what conditions are necessary for life on Earth, no one knows whether these are universally true. Phosphates, which include phosphorus, are essential for the development of all known forms of life. Phosphates are necessary for the construction of nucleic acids, DNA and RNA, cell membranes, energy-carrying molecules, skeletal systems of humans and other animals, and the plankton microbiome in the ocean. The researchers explain that the high levels of phosphates found in Enceladus Ocean exceed at least 100 times those found in Earth's oceans. It's one thing to use a model to anticipate the existence of phosphates, but it's another thing to actually find evidence of phosphates. This is a notable achievement in the field of astrobiology, and represents a significant advance in the search for extraterrestrial life. The oceans of several worlds are covered by glaciers. Over the past 25 years, scientists have recognized the abundance of worlds in the solar system that protect oceans under a layer of ice. Pluto and the icy moons of large planets, such as Titan and Saturn's moon Enceladus, are examples of such objects. These ice-covered ocean worlds can exist at a wider range of distances from the Sun than Earth can support liquid water on the surface, expanding the number of habitable worlds in the galaxy. The research also suggests that phosphate levels would be higher on cold worlds like Enceladus, and possibly other frozen ocean worlds beyond Jupiter. Geochemical testing and modeling show that these high phosphate concentrations originate from improved solubility of phosphate minerals. Enceladus's ocean meets what is often considered the most demanding condition for life. The next logical step is to return to Enceladus to confirm whether the habitable ocean is populated. This remarkable discovery is due in large part to the Cassini expedition, which exemplifies the value of sustained efforts to explore the cosmos through the use of the Cosmic Dust Analyzer. Data analysis by Cassini identified phosphates within grains of salt-rich ice, which played a crucial role in demonstrating the likelihood that phosphates, a form of phosphorus, are abundant in Enceladus's oceans. This is a remarkable illustration of how human-created technology has expanded our access to and knowledge of the cosmos. This study adds to the growing body of evidence that frozen ocean worlds are much more abundant in the cosmos than previously believed. This is because ocean worlds, unlike Earth, can exist at a wider range of distances from their host stars, making them more likely to exist. Now let's go outside the solar system and venture beyond its borders and into the vast and mysterious realm of interstellar space. Since we realize that Earth might not be the only place where life thrives, we have been tirelessly chasing evidence of extraterrestrial life. The consequence of this urgency has been the creation of advanced equipment such as the Perseverance rover on Mars, the Hubble Space Telescope, and of course, the jewel in the crown, the James Webb Space Telescope. Since its launch, the James Webb has embarked on a constant mission to explore outer space in all directions and search for any evidence that suggests the existence of life beyond our planet. From tracking biosignatures to viewing the most distant galaxy cluster ever seen, James Webb is constantly discovering the new. In its early days, the Webb telescope has recently revealed that rocky alien worlds likely harbor abundant amounts of water even before their formation. Now let me explain why this is of great relevance, and what implications it has for the continued search for extraterrestrial life. As we all know, water is an essential source for supporting life on Earth. Scientists apply similar logic to searching for life in the universe. This has triggered the search for exoplanets that are in the habitable zone and contain a certain amount of water. However, many scientists continue to debate how water could have reached the Earth's surface. According to previous research, it is believed that Earth received much of its water from water-bearing asteroids that bombarded our planet's surface during its formation. Now, scientists have discovered evidence suggesting that water must have been one of the components available at the time of birth, which came together to form a rocky planet. Recently, researchers have focused on a young star, PDS 70, which is nearly 370 light-years from Earth and is about 5.4 million years old, compared to about 4.6 billion years old for our own star, the Sol. Using James Webb's infrared instrument, scientists have discovered water in the form of hot vapor at about 625 degrees Fahrenheit near the center of the disk of gas and dust surrounding the star PDS-70. The lead author of the study, an astrophysicist, Julia Perrot, mentioned that this discovery demonstrates that water is present in the inner disk of this iconic system, where Earth-like planets could be forming. This finding is significant since, in our solar system, this central area is where several rocky planets formed, including Earth. By observing it, we can trace how the planets in our solar system formed and what their chemical composition was before their complete formation. The new findings suggest that any rocky planet that forms in the central zone of PDS-70 would contain a substantial amount of water and could eventually become habitable. As for how the water got to PDS-70, the researchers raised two possibilities. One explanation suggests that the water present in PDS-70 could have come from a water-rich nebula that formed the star. Another possibility is that the outer edges of PDS-70 could have been penetrated by oxygen and hydrogen gas, which then combined to form water vapor. If you think that this is an isolated case where James Webb has hinted at the possibility of extraterrestrial life, you are completely wrong. Let me take you through one of the most fascinating recent incidents. Astronomers using the James Webb Space Telescope have discovered evidence of complex organic molecules similar to smoke or soot in a distant galaxy. This is the oldest known sample of complex organic molecules in the universe found by humans. What it has achieved is that it has advanced the previous record for detections like this by about 1 billion years. I don't know about you, but it's both fascinating and terrifying to me that these discoveries at the edges of the universe are changing the foundations of our cosmology. This is a powerful discovery, and here's what changes. First things first, these chemicals have been detected within an early galaxy that formed when the universe was about 10% of its current age. Carbon-based molecules, technically known as polycyclic aromatic hydrocarbons, are found in oil and coal deposits on Earth, as well as in smoke. But what is the importance of this finding? Justin Spiker, the lead astronomer on the study, makes clear that the molecules we found are not simple things like water or carbon dioxide. We're talking about large, flexible molecules with dozens or hundreds of atoms in them. Isn't it amazing that the universe can create really large, complex molecules very quickly after the Big Bang, when our models suggest they couldn't have done so? Given the galaxy's great distance, the light astronomers detected began its journey less than 1.5 billion years after the Big Bang. The universe is currently about 13.8 billion years old. We are looking at the beginning of the formation of the universe as we see it today. But here's the key. It's thanks to the James Webb Telescope that we've been able to detect these complex organic molecules, surpassing the previous record for detections like this by about 1 billion additional years. Imagine if we could look even further back in time. Is it possible that we would find more of these molecules and also very close to the Big Bang? Where does that leave our science, our cosmological model? What's especially intriguing is the contrast between previous efforts to identify complex organic molecules in ancient galaxies and the new level of detail that the James Webb Space Telescope is providing. Previously, scientists could determine in a general way whether these substances were present or not in these distant galaxies. However, with the resolving power of the James Webb, we are witnessing a remarkable advance, as we are now able to delve into the intricate details of the exact location of these molecules within a galaxy. Turning our attention to an early galaxy designated DSFG 850.95, an additional mystery arises. We cannot ignore that the distribution of these complex organic molecules in this galaxy is not homogeneous, but rather presents peculiar patterns. The reasons behind this variability still require further explanation and analysis by scientists. This complexity adds a new level of questions about the chemical and physical processes that influence the formation and distribution of these molecules in the early stages of the universe. This discovery not only opens new perspectives on galaxy formation in the early stages of the cosmos, but also raises exciting questions about the abundance of materials essential for life in these remote environments. What was once considered a period of relatively little activity in terms of galactic formation is now presented as a crucial moment where galaxies were already taking shape and content. It is even more surprising that this early galaxy, despite its youth in cosmological terms, already exhibits comparable magnitude and richness in elements such as carbon and oxygen compared to our own much older Milky Way. The relationship between its mass and the formation of chemical elements is an intriguing testament to the evolutionary processes and fundamental forces at work in the early universe. As humanity continues its exploration of the unknown, supported by increasing knowledge and an unwavering desire to understand the cosmos, we find ourselves inevitably humbled by the immensity and complexity of the universe. With each step forward, our understanding sharpens and we get a little closer to unraveling the secrets that are carefully hidden among the stars. The wonder of how the James Webb Space Telescope is playing its part leads us to firmly believe that the universe is about to reveal itself in a new light, in a perpetual dance of discovery and wonder. Now, I would love to hear your thoughts and opinions on this fascinating scientific advance.